This video is on section 3-7 on equations of lines in the coordinate plane, and we will be reviewing some ideas that you learned last year in Algebra 1. Looking at slopes of lines and equations of lines and graphs of lines. And what we're doing is preparing you for section 3-8, where we look at how these ideas are related to parallel and perpendicular lines. So by the end of this video, you should know what the slope is and be able to find the slope when you're given a graph or two coordinates. You should be able to graph a line when given an equation in either the slope-intercept form or the point-slope form. You can also write an equation of a line in slope-intercept form when you're given the slope and the y-intercept, and also that you can write an equation of a line in point-slope form when you're given two coordinates. This video and the next section is to help you with Geometry Standards G.4.1, that you know the relationship between lines in the coordinate plane, meaning on a graph, and their equations. All right, let's begin by talking about the slope. I would define the slope to be the measure of how steep a line is. So if a line going from left to right is going up, then we would consider that having a positive slope. If it from left to right it's going down, we would think that having a negative slope. This is positive, this is negative. Or if it's horizontal, that has a slope of 0. So it's a measure of how steep the line is. Now the book's definition is a ratio of the vertical change to the horizontal change, or what we call the rise over the run. So we measure the slope by finding the rise over the run. Now when we have two coordinates, the rise will be given to us by y2 minus y1, the change in the y values, and the run is the change in the x values, or x2 minus x1. So this equation right here is very useful for us when finding the slope when we have 2 points. And this is a really useful formula to memorize because it was used last year, we'll use it this year, and it'll be used as you go on in math. So let's practice finding the slope from a graph. Okay, so I have 2 points right here that fit nicely on the grid. And so I will draw this right triangle, and I'll look at the rise and the run. Now, I'm going to go from left to right, so I'm going this way, and then I'm going up. So the change in the y, or the rise, is going to be a positive 3 because I'm going up 3. And the change in the x is positive, let's see here, 1, 2, 3, 4, 5, 6. 6 because I'm going in the positive x direction, 6. So the slope is equal to the rise over the run, or 3 over 6, which simplifies to be 1/2. Okay, number 2. Again, right here and here, it crosses the grid nicely. And so I'll go from left to right. So I'm going down first and then to the right. Now, when I'm looking at the rise here, I'm going down. And so the rise is a negative 3 because I'm going down. And the x is still a positive 2 because I'm going in the positive x direction. I'm going right. So the slope is still the rise over the run, which is a negative 3 over 2, which is the slope. All right, let's practice finding the slope when you're given 2 points. Now, when I have 2 points, I go directly to that equation of m equals y2 minus y1 over x2 minus x1, or the rise over the run. And I'll plug in points. Now, it doesn't really matter how you name the points, but for ease, I typically call this one x1 and this one y1, and this one x2 and y2. Okay, so my y2 is 8, my y1 is 0, my x2 is negative 6, and my x1 is 2. So 8 minus 0 is 8, negative 6 minus 2 is a negative 8, and 8 divided by negative 8 is equal to negative 1. So the slope of the line through these 2 points is negative 1. Okay. Now in number 2, find the slope of the line passing through these given points. Again, I will use m is equal to y2 minus y1 over x2 minus x1. Again, this is x1, y1, x2, and y2. So y2 is 2 minus y1 is a negative 2. So it's 2 minus a negative 2 divided by 4 minus a negative 2. Let me go down here. Now 2 minus a negative 2 is the same as 2 plus 2, or it's 4. And 4 minus a negative 2 is the same as 4 plus 2, or 6. And 4/6 simplify to be 2/3. So the slope of this line is 2/3. Okay, now again to review that a positive slope reading from left to right is going up, negative is going down, 0 is horizontal, and if it's vertical, it's thought of having an undefined slope. Okay, so let's move into equations of lines, and the slope-intercept form of an equation is in the form y equals mx plus b, probably a really common form of a line that we look at. And the m is the slope, and the b is the y-intercept. So if we're graphing this line, the slope is the number that's in front of x, okay? And the 3 is the y-intercept. Okay, so when we graph this, I will begin with the y-intercept. So it crosses the y-axis, which is this axis right here, at 3. At 3. Okay, now the slope is 2. Now, if you want to think of that as a fraction, it's 2 over 1, which will help us see the rise and the run. So from here, I will go over 1 and then up to 2. Or the other direction, down to over here. So that I go over 1 up to, over 1 up to. And that'll give me the equation, sorry, the line. Okay, so I start with my y-intercept of 3, and then I kind of draw off points that would give me a slope of 2. Okay, question 2, write an equation of a line with a slope of negative 2 and a y-intercept of 5. Well, the equation of the line is y equals mx plus b, and the slope, m, is negative 2, and the y-intercept is 5. So the equation is y is equal to negative 2x plus 5. Okay, let's move to the point slope form. Now the point slope form is a little longer, where you have y minus y1 is equal to m parenthesis x minus x1, where x1 and y1 is a point on the line, and m is the slope. Okay. Now, although it's a longer equation, this one is very useful to us when we have the slope and a point. So if you want to graph the line, y plus 2 is equal to 3 parenthesis x minus 1. We'll need to pull out the slope, which is 3, which again is 3 over 1. And the point that it goes through, if you think about the fact that it's y minus y1 is equal to m parenthesis x minus x1, that there are minuses before these. Okay, these minuses are really important. So that means x1 would be equal to a positive 1, because it's x minus x1. And the y1 would have to be a negative 2. So that y minus a negative 2 would be y plus 2. So the point that this goes through is the point 1 comma negative 2. Okay, I hope that makes sense. So I go on my graph to the point 1, negative 2, which is right here. And I use the slope of 3 over 1. So I go over 1, up 3, over 1, up 3, and down this way as well. Okay, so this is my line. Okay, number 2, write an equation of a line with a slope of 3/4 that passes through the point negative 4, 2. Okay. Well, the equation is y minus y1 is equal to m parenthesis x minus x1, and my slope is 3/4, and the point is negative 4, 2. So I will plug this as x1, and this is y1. So it becomes y minus 2 is equal to 3/4 parenthesis x minus a negative 4, or x plus 4. Notice that this negative made it into a positive, which is the same idea that we had to use up here. Okay, and although we may want to simplify this, if we're writing the equation in point slope form, then we're done. We can leave the equation in this form. All right, use the given information to write an equation of each line. Okay, so we have 2 points, and so I will use those 2 points to first find the slope, and then use that slope and one of the points to write an equation in point slope form. So the first step is to find the slope. M is equal to y2 minus y1 over x2 minus x1. And so this is x1, y1, x2, y2. And it's negative 2 minus 6 divided by 4 minus 0. And negative 2 minus 6 is negative 8. 4 minus 0 is 4. And so I get a slope of negative 2. Okay, this is my slope. And for the point, I will pick whichever point I think is easier. Okay, because there's a 0 and no negatives, I think this is a little bit easier. And so I'll write the equation of the line using this slope and that point. Y minus y1 is equal to mx minus x1. Y minus, let's see here, y1 is 6, m is negative 2, x minus 0. Okay, now I could leave it in that form and that would be fine. If you want it in slope-intercept form, then I would need to distribute the negative 2 and then add the 6 to both sides. But I'll leave it like that. Number 2 passes through negative 1, 8, and 5, negative 4. Again, we will find the slope using y2 minus y1 over x2 minus x1. That's x1, y1, x2, y2. So it's negative 4 minus 8 divided by 5 minus a negative 1, which is equal to negative 4 minus 8 is negative 12. 5 minus a negative 1 is 5 plus 1, or 6. And again, we get negative 2. Whoops. Okay, so then we pick the point that we think is easier, and I'll just pick this one. And our equation is y minus y1 is equal to m parenthesis x minus x1. Y minus the y coordinate would be 8. The slope is negative 2. X minus the x coordinate of negative 1. So x minus a negative 1 is x plus 1. And this is the equation of my line in point slope form. Okay, I hope that was a good review of Algebra 1, that you can find the slope of a line when given a graph or 2 coordinates, that you can graph a line when it's in slope-intercept form or point-slope form, and that you can also write equations in slope-intercept form or in point-slope form.